Lesson 5.5, Proving Triangle Congruence by SSS. SSS stands for side-side-side congruence postulate, and it says that if three sides of one triangle are congruent to the three sides of another triangle, then the two triangles are congruent. So true or false? Are these two triangles congruent? And you look at that and say, yes! I see the three sides of one triangle are congruent to the three sides of the other triangle. But then we have to check and see, are the order of the letters correct? So our first two letters, DF, is that congruent to HJ? Yeah. Let's check the last two letters, FG and JK. FG, JK. Yep. And then our first and our last are DG and HK. Yes. So the order of the letters is also correct. So true, they are congruent. Well, how about these two? Well, it says AC be congruent to AC. Yep, they're both 9, same line. CB and AD. CB is 7 and AD is 7. But the first letter and the last letter, AB and CD, are not congruent. This one's 3 and that one's 4. So since that's not congruent, it is false. The triangles are not congruent. Hey, let's write a proof. All right, so how do we start a proof? That's right, we write the givens. AB is congruent to DC, and AD is congruent to BC, and that's given. Statement 1 and statement 1, and it's marked in our picture already. If I want to prove these triangles congruent, I need to have something else, and looking at them I see that they share DB. So I could say BD is congruent to BD by, what is it? If it's the same thing, that's right, it is reflexive. And so now I have the three sides of the one triangle congruent to the three sides of the other triangle. So we can just say triangle A, BD is congruent to triangle CDB by, well, it was side, side, side. All right, so because triangles, if you have the same sides, the same lengths of sides, are congruent, they can't ever change to be any other triangle. So that means structures made out of triangles are very stable. They can't bend or move very easily. So a figure is stable if it's made out of triangles. So is this first one stable? No, it's not made out of triangles. How about that one? Yes. It's made out of two triangles. How about that one? Oh, well, I see one triangle, but wait, what's the bottom? Nope. The bottom part is not a triangle. So it's not stable. The bottom part can move. The top part would not move. Right triangles are special because if we know two sides are congruent, we can use the Pythagorean theorem, which we'll come up with later in a later chapter, to show that the third sides are congruent. So if we have a right triangle, then the longest side, which is also opposite the right angles, this is the longest side, and it's always opposite the right angle. It's the hypotenuse. The other two sides are both legs, and they're shorter than the hypotenuse. So this brings us to the HL theorem, hypotenuse leg congruence theorem. And it says if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the two triangles are congruent. So these must be right triangles. So for congruence theorems, we have to have three parts, like side, 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 or side, angle, side, or in this case, HL and right triangle. So the way this works, and why it's in the section, because we could use the Pythagorean theorem to find the third side for each of the triangles, and they will be the same, so then the triangles will be congruent by SSS. So this is just a shortcut. It's HL, if you know it's a right triangle, hypotenuse and leg. Let's try another proof. All right, so first step, that's right, the given. So write down the given. Angle ABC and angle BCD are right angles, and AC is congruent to BD, and that is given. And that's marked on our picture. So looking at our picture, what theorem are we going to use? Well, we can probably say BC is congruent to itself. By what reason? That's right, reflexive. All right, so we could use, what could we use? Well, if these were right triangles, we'd have hypotenuse and a leg. We have the right angles, but we haven't said anything about right triangles. So we are going to say, we have to say something about right triangles. So we could say triangle ABC and triangle BCD are right triangles. Because if we're going to use HL, we have to say that they are right triangles. And how do we know they're right triangles? Well, what are right triangles? Right triangles are triangles that have a right angle. That is the definition of a right triangle. So now we have our hypotenuse is congruent, we have a leg congruent, and we have the right triangle. So now we can say, step 4, triangle ACB is congruent to triangle DBC because of HL.